Tanker calculation. First of all, thanks to Captain Rajiv. He has a website, www.myctime.com. Okay. All the information I am about to discuss in this video, I took it from this website. This was written by Captain Rajiv. Okay, so if you have any doubt and the methods I am using or the steps I am telling, please refer to his blog. He has explained everything very beautifully. Okay, so for tanker calculation we need ASTM tables. Okay, ASTM tables, that is Americans for testing materials. Okay, this ASTM tables we normally use table number 54A, 54B, 6A, 6B. Okay, the tables with A are for crude oil. Okay, B is for product. Okay, this 54 is used for 15 degree standard temperature, 15 degrees Celsius. This 6 is normally used for 60 degree Fahrenheit temperature. Okay, now normally all over the world use 15 degree temperature and metric system, metric cubes and metric tons. Okay, but some people, especially Americans, use Fahrenheit, and instead of density they use something called API, and instead of metric cube they use barrels. Okay, now what is API? API is the short form for American Petroleum Institute. Okay, so the specific gravity of the cargo and the API is having a relationship. Okay, so what is specific gravity? Specific gravity is nothing. It is density of oil divided by density of water. So actually the ratio of density of the oil with the water, it is called the specific gravity. So it is both ratio is between two same units. Specific gravity has no units. Okay. Okay. Now to find out API is having a formula 141.5 divided by specific gravity, okay, not into the whole bracket, minus 131.5. This is a formula for finding out API of a cargo if the specific gravity is given. Okay, Now another term we are using for calculation is standard density. What is called standard density? Actually, it is nothing. The density, nothing bigger. It is density, normal density of oil. Okay, it is measured at a temperature of 15 degree. This 15 degree is throughout the world for calculation purpose. It is a standard temperature. Okay. Kulfi bell is ringing. I am in Chennai. Night time the Kulfi guy will come. Okay. Now standard density is 15 degrees and at the standard temperature. Okay. Now what is another thing? 1 US barrel. Sorry. US barrel. US barrel is 6.2898 into 1 metric cubes. Basically, 1 US barrel is equal to 6.28 metric cubes. So, if you want to convert 50 metric cubes to US barrel, then this figure into 50, you will get that much US barrels. Sorry. 1 barrel is equal to this much metric cubes. So if you have I got confused, aren't I? Yeah, I'm sorry guys. I just checked in online and checked the blog again. This is wrong. So I send a mail to that captain also to correct it. But it is actually not this way. I'm going to write it. It is actually 1 US barrel is equal to 1 metric cube divided by this value. So I'm going to write it. Okay. 1 metric cube divided by 6.289. It will come around 0.15. So around 153 liters is 1 barrel. That is the correct answer. Okay, so I will write it clearly once again for future reference. Is equal to 1 barrel US barrel is equal to 1 metric cube divided by 6.29. Okay, this value. Okay, and I am sorry for that. And now let's continue. Now, and in the previous one, not this one only. This since it is API is having this formula 141.5 divided by specific gravity minus 131.5. This value specific gravity is at 60 degree Fahrenheit. Okay. Now, what is Fahrenheit? Okay, we all know 0 degree temperature is 32 Fahrenheit. So some people blindly add degree Celsius plus 32 as Fahrenheit. No, that is not the actual way. Okay, actual formula is degree in Fahrenheit is equal to normal degree Celsius value into 1.8. You have to multiply with 1.8 plus 32. Okay, so normal situation for 0 degree Celsius, the Fahrenheit will become 0 into 1.8 plus 32. So 0 into 1.8 is 0, then 32 is the value, then that's why 0 degree is 32 Fahrenheit. But in other cases 1.8 will be added, so that will come for 1 degree Celsius, that will 33.8. Like this it will, yeah, go up. Okay, and what? So now the weight. Okay, now we talked about the density, the volume, standard density, specific gravity, and everything. And another thing is weight. Okay, so for after the calculation, when we get weight, there is two type of weight. Okay, weight in air and weight in vacuum. Okay, now you may be thinking, what is weight in air, what weight in vacuum? Both are weight, but weight in air is lesser than weight in vacuum. Okay, because there is something called air buoyancy. Okay, so if this is a ball, the air pressure will exert some pressure on the surface of the ball, and gravity, the center of gravity, like downwards at 9.8. Okay, so there is some effect of air pressure acting upwards. Okay, so ball is smaller area, smaller surface area, so according to the air pressure acting on throughout the surface, lots of acting in all direction, but some is acting from down to up also. Okay, so it will feel a, the object will feel a buoyancy, and that buoyancy will reduce some amount of weight. Okay, so to find out the actual weight without any buoyancy effect of air, you should calculate the weight in a condition where no air, that is called vacuum. Okay, okay, so if you place a ball in a closed container and there is a weighing machine. Okay, and on the surface of the earth, the weight showing will be more than what showing here, less. Okay, that is because of the air in here, and here the air is sucked out and created a vacuum. Okay, so when you are doing calculations, this difference is minute for small objects, but for bigger objects, for example, for 100 ton, 10,000 or 100,000 tons of cargo and weight in air and vacuum, there will be significant hundreds, so maybe 10, 100 tons, I don't know. Okay, that much of difference, and when you calculate, then only you will know. So for that purpose, we always calculate weight at air and weight at vacuum. Okay, so the density, we all know that weight is equal to sorry, yeah, weight is equal to volume into density. Okay, so the normal density given at 15 degrees Celsius is actually weight in vacuum. Density at vacuum. Density in vacuum. So when you multiply with the normal standard density and the standard volume, you will get a weight in vacuum. Okay, I will tell you standard volume and standard density. Standard density is the density of a liquid measured at 15 degree. At 15 degree temperature, what will be the volume of the liquid? That is standard volume. I think I measured that, right? Sorry, I mentioned that. Yeah, standard density I already mentioned. Okay, so now okay, so density is 15 degrees density in vacuum, and if you want to find out the weight in air, you need to have the density in air. So there is a formula: density in air is equal to density in vacuum minus 0.0011. I don't know why it is 0.011, but it is a standard value. So if you subtract this value with the density in vacuum, you will get a density in air. Okay, so when it is also sometimes it's called as weight correction factor. See, okay, weight correction factor. Okay, leave it like that only. Now, important thing, we cover the density, weight in air, weight in vacuum. Now, temperature. As the cargo temperature increases, volume will also increase. Basic physics. So, as the volume increases, density will reduce. Okay, so density is mass divided by volume. So the volume as this volume part increases, density will reduce. Okay, because the entire ratio has to remain a constant. If this increase, this has to reduce. And okay, there is something called VCF. That is called volume correction factor. Okay, then why this VCF is used? Okay, so cargo during the loading, cargo temperature, let's say 25 degrees Celsius. Okay, and you don't know the density at 25 degrees Celsius. What you know is density at 15 degrees Celsius. So you only have the volume. Sorry, not this one. So from tank ullage, you will ullage tables. You get cargo volume, right? This cargo volume into density will give weight of the cargo. Now this cargo volume is calculated at 25 degrees Celsius because you are taking ullage and you are getting measuring temperature also. So the volume of cargo at 25 degrees Celsius into density at 25 Celsius gives the weight. Okay. Unfortunately, you only have cargo volume at 25 degrees Celsius. You don't have density at 25 degrees Celsius. So, to find out the weight of cargo, either you have to find out 25 density, or you have to bring the volume of the cargo from 25 degrees Celsius to 15 degrees Celsius. If you can bring the cargo volume from 25 degrees Celsius to 15 degrees Celsius, the density is known, because it is a standard temperature. Every cargo has a standard temperature density that will be provided by surveyor. Okay, MSDS also have. Okay, so to bring the observed cargo volume, because this is the cargo volume you observed at 25 degrees, observed volume to standard volume, you need to multiply the observed volume with a factor, and it will bring that volume to standard volume. That factor is called volume correction factor. Okay, it is actually correcting the standard volume, observed volume to standard volume. Okay, so after applying the volume correction factor to the observed volume, you will get a standard volume. Then you multiply standard volume with the standard density. Okay, so standard volume into standard density, you will get a standard weight at 15 degrees Celsius, standard density. So like I said earlier, the standard density at 15 degrees Celsius is actually density in vacuum. Okay, so if you want to find out the weight of the cargo in air, you need to multiply density in air with the standard volume. So density in air is equal to density in vacuum minus 0.0011. Okay, if this looks little messy, I'll write once again in the next page. Okay, density, first of all, standard volume, once again, observed volume into VCF, which is volume correction factor, will give you standard volume. Standard volume into standard density will give you standard weight. Okay, that is in vacuum. Okay, now standard volume into density in air will give you standard weight in air. Okay, density in air is equal to density in vacuum minus 0.0011. Okay, So this is how the calculation is done. So you will get a standard weight in air and standard weight in vacuum. Okay, this is the final quantity we have received. So just for one practice, I will show how a alleged table looks like. Okay, alleged table normally looks like tank allege. This is normally observed allege, that what we measure from the sounding pipe, sorry, allege pipe. And water dip, that is interface. Okay, and 1 2 3, no, let's number it. Okay, corrected allege. Now the fifth one is water dip and corrected allege, and observed volume. Now the sixth one is VCF. Okay, volume correction factor. Okay, now the seventh one is standard volume. Okay, now the eighth one is density at 15. This is what? Vacuum. Okay, now you normally we can say WCF, volume correction factor. Okay, now the other part is 10, density at air. Okay, now next thing is 11, weight vacuum. 12th one is weight air. Okay, so it will form like in Excel sheet, it will like columns, cells. Okay, now this is tank number 1, 1 port, 1 starboard, 2 port, 2 starboard. Allege will be whatever you get, 1.25, 1.35, 1.25, 1.30, like that. If there is no water interface, write nil. Maybe 1 centimeter in one tank, 2 centimeter in one tank. Okay, now the corrected allege. Since there is no water, this allege will be same as corrected alleges. Okay, now in this case there is 1 centimeter of water, so the corrected allege is equal to 1 plus 1.25, so you will get 1.26. Now you should be thinking, you must be thinking why you add 1 centimeter. Okay, so this allege is for finding the cargo space, so not the other way around. So in 1.25 meter allege, 1 centimeter is water. That means 1 centimeter is not a part of cargo space. So only that much, 1 centimeter is less. So if there is no water, then instead of 125 the allege would be 126. Okay, similarly in this tank 132. Now you go to tank allege tables, calibrated allege tables for all these allages with the respective tanks and allege. You will get volume. Okay, I am not writing because this is imaginary value I wrote. Okay, now this is observed volume. This is what you observed right now. Now you will add volume correction factor to the observed volume. Okay, so you will get a standard volume. That is, to get a standard volume you have to multiply 5 into 6. Okay, observed volume multiplied by 6, you will get a VCF for different cargo and different density will be different if the cargos are different, or if it is a product tanker and different tanks have different cargo, then it will be different. If it is a single grade, then VCF will be a single number. So standard volume of each tank you will get. Okay, now the density of the each cargo in each tank. If it is same cargo in all tanks, only one figure, otherwise different density. That will be, this density will be given by shipper or surveyor. Okay, and you multiply this number 7 standard volume with the standard density. What you get? You get standard weight. Okay, standard weight in air. That standard weight in standard weight in vacuum. That is here 7 into 8. Now weight correction factor, that is 0.011. This one is common. This purple is common for everyone. Okay, so you subtract this fellow with the weight in density in vacuum, you will get a density for each cargo in air. Now you can multiply density in air with the standard volume, that is 7. You can multiply 7 and 10. You will get weight in air and weight in vacuum and weight in air. So for all the tanks individually you will calculate like this, and find at the end you will tally up. Okay, and similarly you will tally up the standard volume also. Okay, this is final calculation. Okay, now it's almost half an hour. Thank you, and I'm sorry for the mistake I have made in about US barrels. Thank you.